Okay, we're going to talk about laws of exponents today. We are going to simplify numerical and algebraic expressions using the law of exponents that include integer and rational exponents. So as a quick review, you know that a power is an expression that includes a base and an exponent. One thing you need to keep in mind now is that your bases can now be a variable. So you've been used to dealing with your bases being numbers. Now they can be a variable, and that's what today's lesson is. It's focusing on how can I simplify a power when one of my bases or more than one of my bases is a variable. So remember that an exponent tells you how many times to use the base in multiplication. So we have 5 times 5 to the power of 2 here. That really is 5 being multiplied twice because my base is 5 and the exponent tells me to multiply the base twice. And so if I multiply 5 times 5, I will get a result of 25. Now the most common mistake kids will make is they will say 5 times 2. They will take the exponent and the base and they will multiply and they will get an answer of 10. And that is wrong, okay? So you need to remember that this is not correct. We do not multiply our base and our exponent. We use our exponent to tell us how many times to multiply the base. All right, so let's start into our laws of exponents. So there are 5. So these are something you are going to have to memorize when you start practicing on your own. If you do not memorize the laws, you will not know what to do with your exponents. And keep in mind, this is a law of exponents. So these are telling you what to do with the exponents, not what to do with your bases when they are numbers. Okay, so the first thing you want to do is a power to a power. The first thing you've got to recognize when you have a power to a power is not only are you going to see parentheses, but you are going to see an exponent inside and outside the parentheses. If you do not see an exponent outside the parentheses, you may be looking at multiplication, which is a different law. Okay, so for power to a power, what you're going to do is you are going to follow the arrows. You are never going to use the operation in the exponent law that's in the name. For example, I am not going to raise 3 to the 4th power to get my new exponent. I am actually going to use a different operation, and that operation is multiply. So if I wanted to rewrite this very simple power to a power, I would write my base of k, and then I would multiply my exponents. And 3 times 4 is 12. So I would rewrite this as a single base of k with a single exponent of 12. That is what we're doing when we are trying to simplify. Okay, so let's look at the next thing. After power to a power, the next law you want to look at applying is the law of multiplication. So here I have 4 times x to the power of 2 times 3 to the power of x. So what we are going to do is we are going to apply the law of multiplication or the product rule for laws of exponents. So if you notice, you have 2 bases here. I have a base of x, which I'm going to double underline. This x has an exponent of 2. And then the other x also has an exponent. It's an invisible 1. So if you don't see an exponent on your base, you need to write that it is an exponent of 1. Okay, it is not going to be 0. If the exponent was 0, that x base would not be there, would not show up. Okay, and I also have numbers that are bases. So don't forget, guys, your bases can also be numbers. So I have a base here of 4, which I'm going to circle. And I also have a base of 3. And the reason why I circle them in the same color is because they're both numbers. So they're both same type of base, okay? So I really have 2 different bases here. I have 2 bases of x and I have 2 bases that are numbers. And I want to simplify them to get an answer where I just have 1 base that is a number and 1 base of x with 1 exponent power. So here's what we're going to do. So we are again going to follow our law of exponents. And since we are multiplying, we are not going to use the law of multiplication. We are actually going to use a different operation. And that operation that we are going to use is we're going to now follow the arrow down to the A. And A stands for addition. So we are going to actually add these exponents together. So I'm going to circle them. So I'm going to get x to the power of what do I get when I add 2 plus 1? I get 3, okay? And you'll notice I skipped over our bases that are numbers because I'm always going to go back to them at the end. So I'm going to pretend that those x's are not there, and I just have now a simple multiplication problem of 4 times 3. Well, what did you learn that the product of 4 times 3 is? It is 12. So I'm going to multiply my bases when they are numbers, just like I would learn my multiplication or my division facts, my addition facts in elementary. So your numbers that are bases are going to work just the same. The only thing that you are going to do differently is you are applying a different operation when you are dealing with exponents. Okay, we're going to look at that more on the back. That's what's going to be the hardest thing to do, is to train yourself to think for a different operation when you are working with exponents. Okay, there is no addition law of exponents, so you're going to do power to a power, you're going to multiply. If you have multiplication, which they may also show by using parentheses, so you got to make sure you don't have that exponent outside. If you have multiplication, you're going to add your exponents. Now, the 2 rules that I have out here to the side, these are going to be the 2 rules that you check after you do PMA. After you check for power, then check for multiplying, and you have to add. Then you check for the quotient rule. You are going to subtract the exponents, which means you've got to look for a fraction bar. That is how we acknowledge and recognize that there is division here. Again, I am not dividing the exponents because it's the quotient rule. I'm actually using subtraction, because if you look over here, when we were multiplying, I added. Well, what is the opposite of multiply? Quotient, divide. What's the opposite or inverse operation of addition? Subtraction, okay? And then the 0 power rule. If your exponent is 0, you are going to replace your base and exponent with a 1.